you have your incubator again at 500 meters altitude or at sea level, your cells will see a very different oxygen level, even if it's a hypoxic chamber. Again, it's not comparable. The sensor, the hypoxic workstation we have has an oxygen sensor in there which measures partial oxygen pressure. So wherever you have this hypoxic workstation, you measure exactly the oxygen your cells are seeing in the incubator. And you can compare your data with other research groups in Denver, Colorado, or Albuquerque, New Mexico, or in the Netherlands, again, like with sea level height. So this is the hypoxia lab I want to introduce. It's an efficient incubator and workstation at the same time. Let's see if it works. Oh no, it doesn't work, sorry. No, the sound isn't working. Sorry, I wanted to show you a quick movie, but it's okay. So the advantages of the hypoxia lab is that it's very compact. You can see compared to the lady next to it, it's not very big. Altogether it weighs about 25 kilograms, so you can take it from, if you have to, from one lab to somewhere else. It's not fixed in one room for the rest of its life. It's economic. It has a very low gas consumption, which is especially, I'm not sure how expensive gas is in Taiwan, but in Europe, like nitrogen is very expensive to buy. So for the researchers, if they need a lot of gas, those big hypoxic chambers are very expensive to run. So because this has a small gas volume, it's cheap to run. Also because it's small, you have a stable hypoxia within 15 minutes and a rapid set point. You get the authentic oxygen, which means, like I said before, because we use partial oxygen pressure, you know exactly in millimeter mercury what your cells are seeing because you're not using a percentage. There's a HEPA filter inside, so it's a very clean environment to work with. And there are, compared to other chambers, there is no oxygen sensor calibration required. You have an active humidification inside by ultrasound, and it's very user-friendly. So to connect the hypoxia lab, you need 3 gases. You need air, you need CO2, and you need nitrogen, and you need a water bottle. And 70% alcohol to spray it clean. We have different add-ons, which I think I'm not going into. Oh yeah, here, that's quite good. I just want to show you. If you, this transfer hatch here, it's like, you usually take that plastic lid off, you spray it with 70% alcohol, you put your medium in, you put your tissue culture in, you put the hood back on, your pipettes, everything is inside, and it takes 20 minutes for 7 millimeter mercury oxygen. And then when you work and you realize you've forgotten something or you need something else, in front of the hypoxia lab there's this transfer hatch. It's larger now than on this picture. We have modified that so you can put flasks through or pipettes or something else. As you can see here, there's a little flap. This flap has a sensor on it, so as soon as you touch that little flap, it will pump extra nitrogen into the chamber to maintain that low oxygen concentration, so that the environment is really stable. We have shelves. We also have a shelf for 50 milliliter Falcon tubes inside where you can store your plates. We have a power to support that little microscope you saw before with 5 voltage, for example. And we have a touch screen again. Now let's do this. The data are saved for 28 days and then they're overwritten. So you can look at your oxygen profile, what happened overnight, if you're not sure. And you can use lab chart, if you have that, or you can download a free software lab chart reader to get these kind of traces. The display looks like that, and it's very easy to manipulate. So basically you tap on the arrows up or down, and then you get 24, 25 millimeter mercury of oxygen, whatever you like. If it's green, it means it has reached that point you've chosen. The same for CO2. So you can set the CO2, you can set the temperature, and you can set the humidity. And the 2 hours here just shows you how squashed the picture is on the display if you want a trace rather than a number. It also tells you on the top how much gas is left in the bottles when you connect them. And here you can turn the light on. So. What you also can do, which is sometimes interesting for customers, you can make oxygen profiles, which means you have maybe 10 minutes at 5 millimeter mercury and then half an hour at 15 millimeter mercury, and you can move that. And again, these cycles happen very quickly because you have not much volume on gas in there, which needs to be changed. That's a nice extra feature. And you see here that's a transfer hatch I just said, where you can put in extra plates. Yeah? So, and below is the display. And here you see the shelf with the dishes, and so you can work in there. So the market basically is for anybody who's doing tissue culture, really. Originally we focus on cancer, then stem cell biology, because the bone marrow has only 15 millimeter mercury as well. Immunology, tissue engineering, and so that's more or less the main applications. And yeah, here just some data. But people have, over the last few years, people have been doing studies comparing tissue culture grown at CO2 incubator with the same cells growing in hypoxic conditions. And here's, for example, stem cells, and they found that they have a better clonogenicity if they grow the cells under hypoxic condition compared to atmospheric or conditions. And here hypoxic culturing increases the differentiation potential of chondrocytes. So here you see they grow much better under hypoxic conditions than under atmospheric conditions. There's another example which says physiological hypoxia enhances the HTLV1 plus strand transcription, for example. So that goes into immunology. Here we have fibrochondrocytes. They find, again, that it works better under hypoxic conditions. Another one, again, physoxic human cell culture improves viability, metabolism, and mitochondrial morphology while reducing DNA damage, because you don't have all the radicals there which cause other which activate other pathways. There's a cancer paper, tumor acidosis and hypoxia differentially modulate the inflammatory program. And again, the last one I've started with, we need to define the physoxia for the tissue culture or for the cell type we are using in the cell culture to make sure we grow it in with the correct oxygen value. So I think that's the hypoxia talk. Any questions to that at the moment? Are there, besides the gentleman here in the front, is there anybody else here working with tumors? Tumor cells? Is there anybody here toxicology, pharmacology? No. We're nearly finished. I'm going to be very fast. And if the gentleman in the front has more questions, we can talk about it afterwards, because I'm not sure if it's so relevant for everybody else here. Yeah. So, but basically, I'll show you briefly an instrument which is called the gel count, which counts mammalian colonies, not cells, mammalian colonies. And it's a very good instrument for a core facility, or if you have more people, more research groups using it. Yeah. Normally, if people do clonogenic assays, survival assays, it's very labor intense because they have to count these type of colonies or these ones by eye. So it's a bit limiting. It's very subjective. Everybody gets a different number when you count. Yeah. And so we've developed the gel count. We had a predecessor called col count, which we had to discontinue because of supply issues. So we've made the gel count, and that's working. It's very, very popular. It's kind of the golden standard now in cancer research for clonogenic assays, because what it's doing really well. It's an integrated imaging and software platform. You can see here you can fit 4 multiple plates, but we also have trays for Petri dishes or T25 floss. It's obviously faster than manual counting, and it's objective and consistent. The other thing is why I said before the manual counting is limiting. This one gives you, besides the colony counts, also statistics as standard, such as nearest neighborhood distance, average diameter. It can calculate a volume if you do a 3D in soft agar. So you have several extra parameters which people find sometimes very useful. It supports the 2D, we call, and the 3D assays. The 2D are the ones where the colonies grow adhesive on the bottom of the tissue culture, and you stain them afterwards with Comassi blue, crystal violet, something to detect them. That's what we call 2D. And then it also does 3D, which is the colonies you grow in methyl cellulose or soft agar. And you don't need to stain those because it works with density, so normally you can see those without staining. If they're very small and would require staining, we have some protocols on the website. You can stain with MTT, for example, but then obviously it's terminal. The data are exported into Excel, and also the images can be exported as a bitmap, or you can store the raw images, which means you can analyze it later on again. So it's like an offline image. And other very good news is that you buy the gel count, you get the license for free, and you get the updates for free. And you can have as many licenses as you want. Which means, like, if you have the gel count in one lab, and you have 20 people wanting to use it, you can install the software 20 times on everybody's computer. You just image in the lab, and you count off-site then. So it's a very good product as a core facility. For example, in Houston in Texas, I think they have 6 gel counts as core facilities at different departments, yeah, and there are many groups using them. Application is obviously cancer, radiation sensitivity research. That's why I asked about if people do toxicology here, because obviously we can do toxicological studies and antibody specificity. And you get the IC50 values for survival curves. And just to show a picture, that's a cut from that's a 6-well plate. It's a second well. You have a magnification of this area. In that plate are over 4,000 colonies. And people normally need to count it by hand. So they're glad you have the gel count to do that for you. You get statistics here. That's how they look unprocessed, the cells. And that's how the data looks in Excel then. You get the plate, the wells, the count, average diameter, area, and so on. And that's just an example from a paper. So it's a radiation one, you have 0 gray, 5 gray, and then with an added drug, upsic and anoxic and different ones. So just to see how the data is presented. And I think I'll stop here and thank you for your attention. And if you have questions, the discussion is open.
Can this machine recognize the fluorescence signal?
Sorry?
Fluorescence signal. Can this
Fluorescence.
machine-
你是要染
一些fluorescence signal can this machine recognize? To measure
No.
fluorescence?
No fluorescence. No, it's really only like stained colonies or those. It's limited in what it offers, but then it's not so expensive. I mean, I think there's one instrument that's called BioReader or so from Bio. I don't know if you've heard, and it's about 5 times or 10 times the price of ours because it has all these options. This one is only doing clonogenic assays, but that with a good throughput and very well. Yeah.
有没有什么想问的？
Any questions?
Yeah.
So does gel count put a threshold on the size of the colony?
No, you put that on. You tell that you have to make 2 settings for each treatment you do.
Yes.
Yeah. One is the mask. Right here. You see that green line? That's a mask. You tell the gel count in which area it should count. Sometimes people say, I don't want all this gray, or we have lots of bubbles on the side. I cut that out. I prefer to just read more inside. So you make a mask and tell it in what area, and you save it as a settings file. So you only do it once, and every time you reuse it, you just use that file. Yeah. And the second thing is, you tell the gel count what it's supposed to count. So you give it an average colony diameter. You say, for me, a colony with 50 cells, with that cell line, needs to be at least 400 microns in diameter. So I'm not taking anything which is smaller than 400. So you make a cut. And then you look at your picture and say, well, if it's more than 2 millimeter, it's not a colony anymore either, so I cut it off at that end. And you can choose by density and also how, especially for mammalian colonies, when they are treated, they don't grow nice, they don't have a nice edge. They grow fringy and not nice. So you can determine the edge, if it needs to be a round edge or a dispersed edge, how circular the colony has to be or not. So you can make some settings. You make that for each cell line, each treatment, and then you just put your plates and you click on the setting, you click on the masking file, and then you say count, and you go for a coffee. And then you come back and put in the next trace. Yeah? So each person has their own settings,
Yes.
and that's quite nice as well when you have different groups using it. So because you save your setting with your name, and say that's my setting, my cell line, and everybody has their own. So nobody can, do something wrong to your software, so to speak. Yeah? You have your own software settings.
Okay, then thank you, Patrick. Petra have very detailed and vast information about the gel count and also light and also the hypoxia chamber. And we will have a short break, then we will have an animal demo in the laboratory that's there. And we will put the oxygen light probe into the brain and to see the oxygen concentration change later. So if you are interested about that, just move to the laboratory later. And also, if you got more questions or additional question about each product or some application in your research, please feel free to ask Petra or ask me. Okay? Okay, thank you very much.
Thank you.